Let's go through LeetCode 3251. Find the count of monotonic pairs 2. So we are giving an array of positive integer nums and with length n. So we call a pair of non-negative integer arrays, array 1 and array 2, monotonic if array 1 has length n and array 2 has length n. And array 1 is monotonic non-decreasing, and array 2 is monotonic non-increasing. And also we need for each index, array 1i plus array 2i equals nums I. So we need to return the count of the monotonic pairs. Let's take an example. Example 1, 2, 3, 2. We can find 4 pairs of array 1 and array 2. So the result is 4. For this question, we'll see for every what we think about is that possibly we try to find from every index I the number of pairs. For example, if we iterate to index I up to index I, we can find for example, if array we have array 1, right? That is monotonic non-decreasing. Array 2, that is non-increasing. And for this I, right? So we know this I has a nums I. And that is if we have array 1, if this number is j, right? We say at this moment we have for example, we use a variable called possibly dp I j represent the numbers of value pairs of array 1 and array 2, so that array 1 I equals j up to index I. So what we think about is that this kind of state is actually dependent on the previous state, right? So that is I minus 1. And for example, array 1, we select k, right? So we know there are 2 conditions. K should smaller equal to j, right? Because array 1 is monotonic increasing, and array 2 is nums I minus 1, right? And minus k, because this is monotonic the first one is monotonic non-decreasing. This is monotonic non-increasing. So that is nums I minus j, right? So we'll see this k and j, right? So k and j, j is at the index I minus 1, right? And array 1 equals k up to index I minus 1. How many array 1 and array 2 pairs, right? So we'll see this k has the condition smaller equal to j, right? And the second equation, we have k smaller equal to nums I minus 1 minus nums I plus j, right? So k and j, they have 2 conditions should be satisfied. K should smaller equal to j, and k should smaller equal to nums I minus 1 minus nums I plus j, right? So what k can choose is that the minimal number of this, right? And also the minimal number of nums I minus one, right? So the minimum of these three. So we'll see if we define RDPIJ, we define this one as represent the number of valid pairs of array one, array two, so that array one I equals J up to index I. Okay, so let's write our DP definition, right? DP should have let's have two dimensional, right? And DPIJ, it represents the counts of valid pairs, array one, array two, so that array one I equals J up to index I. So this is our definition for our DP, right? So what well for our result? So what how can we count the number of pairs, right? That is, we need to sum return the result, return sum of DP n minus one to J, right? This kind of J is probably from J is from the range from 0 to nonce n minus one, right? So we sum up this kind of value, that will be our result. And what is the initial condition? Initial condition is that for every DP 0 J, right? For every DP 0 J, J in the range from 0 to nonce 1, right? We'll set this one as 1. Yeah. Because that is at the beginning of the array one, right? Array one, there is no other combinations. Array one equals array 1 0 equals nonce 0, right? Array 1 0 equals J, right? Because J need to iterate from 0 to nonce 0, right? And since that answer may be very large, so we should mod, right? So let's write a mod private final static int mod equals 1. Okay. So let's write code int n equals nums dot length. And we can have the, for example, because this we need to mod, right? So we should have use the long, right? Long dp equals new int n multiplied by 1001. We can have this one as 1001, right? But to get this efficient, we can get a max, right? For int num. Let's have max equals nums dot um, 0, okay. Max equals max dot max, no, right? So our DP we can open as max plus 1, right? That we have a beta space. So as we talk about, right, for the initial state is for int j equals to 0, j is smaller than nums 0, j plus plus, right? So we'll say initial state, we set array 1 I equals j, right? So that means for every dp 0 j, it is 1, right? We only have one state. Then what we need is just we write the from int I equals to 1, right? I smaller than I plus plus. We are going to have for j int j equals 0 is smaller than nums I j plus plus, right? So we know every dpij they are coming from dp dpi they are coming from dpi minus 1 this k, right? So k can only we have a limitation k smaller equal to j, and another condition is nums I minus 1, right? Minus k, because this is array 2 should greater equal to nums I minus j, right? So k is actually this one convert to k smaller to another formula, right? Should k should smaller equal to the minimum of these two, right? J and this number. So that means our dpij is only from those kind of dp I minus 1 k, which satisfy these two conditions, the k, right? Can be only transit from this kind of case, right? So what we do is that we are going to have for int k equals 0, k small equal to max dot min j, right? And another one is nums I minus 1 minus nums I minus j, right? K plus plus. So this kind of dpij will be the sum of the previous state, dp I minus 1 k, right? And we need a mod, right? So let's have dp I j plus in the mod, right? And in the end, what is our result? We have long result equals 0 L. And for int j equals to 0, j smaller equal to nums n minus 1, j plus plus, going to have result equals result plus bp n minus 1 j, and not return int result, right? Mm, max plus one. Mm, max dot me g k equals 0. So the last one is 126. I will have one more. Let's look at, we may need to debug, right? So let's look at 1007. Is max. So dp, this one equals 1. We should set this one as equal, right? Because this value we also need a set. This is one thing we need to change. And is there any other case smaller equal to k plus plus? Yeah. But this time complexity, let's look at the time complexity. This time complexity, it will be On multiplied by there are two J and K loop, right? So that is the max multiplied by max. And N multiplied by max multiplied by max, that is 2000 multiplied by 1000 multiplied by 1000. It will be TLE for this case, right? So we should do better. So how can we do better? Let's look at this kind of formula, right? This formula, it is just add the previous state, previous I minus 1 dp k from 0 to this kind of range, right? So what we think about is that every time we, instead of we sum up k from 0 to this mean value, we can create a prefix sum for dp that I minus 1, right? And for k, we just check the prefix sum here, right? So we can, so let's change this a little bit to the prefix sum way. So we are going to have int prefix sum. This is a prefix sum of dpi minus 1, right? And this will be whatever k, right? K from 0 index, let's say, equals new, let's use long because we already changed this one to long type, right? It's long. And new long max plus one. Um, we are the things that mm, we are able to set this one to be max, right? So that means that the DP is going to max plus one. Then our prefix sum, let's have one more index. So what we do is that for int k equals one, k smaller, then mm, nonce nonce I minus one, right? Plus plus one, right? K plus plus. So we're going to have dp prefix sum k equals prefix sum k minus one plus dp I minus one. Okay, right? And this prefix sum, we also need to get a model of it, right? So in this case, we can get rid of this for loop. Then we'll say this dp ij, right? dp ij will be prefix sum. So prefix sum case the right end is this kind of formula, right? So we can have if limit equals this one, right? The right end is this. So we have prefix sum limit plus one minus prefix sum there. And this one we also need to mod, right? Let's change right. Mm. Let's just set this one to actually to be max plus two, right? Because otherwise some of the values it will be zero. That will not be correct. Okay. Four. Which one is four? Uh, the reason we are doing incorrect is that it's not a DPI minus one K, right? Should be K minus one because we have one more index. So doing like this, we now let's look at the time complexity, right? So we have ON, and this one is O max. This is another O max, right? So that but this for loop will move outside, so the time complexity will be N multiplied by max. And we can do it better for space, right? Actually, let's look at the space. We may not need the first dimension, so we can get rid of the first dimension, and we set this one as one, right? And the long, we still need this kind of prefix sum, right? That is the dp of the previous round, dp I minus one for the prefix sum, right? And we have dpi. And one of the things that if we do the prefix sum, right, and we need to have add one more condition is that if limit greater equal to 0, then we are going to have dpij equals this. Otherwise, it is possible the limit become smaller to 0, right? And when we convert this one to be one dimension, right? And we should add else dpj equals 0, right? Otherwise, dpj will be carried from the previous round. So get rid of dp the a minus one, right? So one thing is that we should move this kind of prefix sum array outside. Because otherwise, for every I, we create a new array. The space is not good. So doing like this, we'll see the time complexity will be n multiplied by max, and the space will be O max. And we can convert this one to Python code. So we also need to have a mod equals one. Let's put this inside, doesn't matter. And we have n equals length now. And we're going to have next number equals next month. And we need let's say we use one dimension, right? Dimension dp equals 0 multiplied by max number plus 1. And for initial state is that because every array 1, for every j from 0 to array 1 0, right? So because our DP is defined for DPIJ is up to index I, the the pair of array one and array two, that array one I equals j, how many possible solutions, right? So for the first index, it can only have one, right? So what we do is that for j in range norms 0 plus 1, we're going to have dpj equals 1. And as per we talk about, we are going to for I in range 1 to n, right? For k in range, we need a prefix sum, right? Prefix sum here. Prefix sum equals multiplied by next plus 2, next number plus 2. In range 1 to next number plus 2. We have prefix sum k equals prefix sum k minus 1 plus dp k minus 1, right? Because we will for prefix sum we have one more index, and let's have get a mod, right? And what we do is that for j in range from nums I plus 1, right? We have limit equals mean j and nums I minus 1 minus nums I minus j, right? So we'll say if limit is greater equal to 0, then we'll have dp j equals prefix sum limit plus 1 minus prefix sum 0, and we should mod. Otherwise, else we have dpj equals 0. And in the end, we sum up the dp I minus 1 j, right, to j from 0 to nums I minus 1. So we should have result equals sum dp j for j in range nums a minus 1, right? Plus 1. And for this one, we also need a mod, right? And then the return result.
Okay.